So for those of you who are joining us just this afternoon, welcome to ZEDEDA Transform 2021. My name is Stephanie Atkinson. I'm the CEO and founder of Compass Intelligence. We are a market intelligence and advisory firm serving tech companies specific to IoT, mobile, and emerging technologies. And I've been doing this for more than 16 years, so I'm really happy to get on this session with you guys today. This is one of our breakout sessions. I'll be your moderator today. This is the State of the Stack 2021. And we, overall, I think I'm happy to be a part of this. This is one of the best events out there that showcases anything and everything edge. And I'm happy to be a part of this today. This is essentially where the industry is embracing. As we automate, we're operating and we're transforming our businesses. So today, we're going to talk about tech trends and the stack. And before we get started, I'll just briefly touch on what the stack is. Some of you guys are knee deep in this and have been doing this for a long time, so it's very basic to you. But for those that are kind of getting into the game, the stack is basically a range of technologies. And think hardware, software, platforms, connectivity, along with standards and applications and or software. It's basically the things that we use to connect the assets, equipment, people, systems, and things to the internet. And there are varying models that outline the IoT stacks, and even some of those that even define edge stacks, but all include physical, network, transport, and application layers. So the stack is essentially all the protocol standards and tech that enable enterprises and governments to make this stuff happen. And this may include things like routers, gateways, sensors, radios, connectivity, software, endpoint devices, a whole range of things. So now that we've set the stage for our topic today, our goal really is we want to discuss the current trends happening in the IoT and edge computing space, including where we've been and where we're headed. So before we get started on our discussion, I'd like for each of our panelists to briefly tell us who you are, what you do, and your areas of focus at your company. And first, we'll start with Sam.
All right, thanks, Stephanie. I'm Sam Armani, SVP Business Development at Mimik. At Mimik, we have developed and commercialized a hybrid edge cloud platform, which is an application development platform with a series of business enablers for app developers in every industry vertical, enabling them to develop their apps faster, more efficiently, with an innate capability to communicate directly with other apps and devices, and using the cloud resources only for global functions. This is to enable faster processing of data at the edge, to drive knowledge for faster decision making, improved privacy, security, lower cost, and at massive scale. And it's a pleasure to be here with you all today. You are on mute, Stephanie.
Thank you. Sanjay, you want to give us a brief intro to yourself?
Yeah, absolutely. So this is Sanjay Kumar. I'm based in the Metro Detroit area here in Michigan in the US. Any of those of you who are calling in from outside the country. So I am responsible for Siemens Edge to Cloud solutions that ranges from Siemens Industrial Edge to our industrial IoT platform and the applications. In addition, also our low-code, no-code platform. I started my career in the plant automation business in manufacturing, progressed through different consulting roles in the industry. I led building telco's IoT professional services organization. And now with Siemens, we work with clients to help them figure out how they can leverage this stack as they look at different initiatives in manufacturing, connected products, or other different use cases.
Great, thank you. And Andrei, we'd love for you to give us a brief intro. And you're coming in from you, so welcome.
Hi, thank you, Stephanie. So Andrei Ciobotar, CTO with relayr. We're a company focused on IoT in the industrial space. We're part of the Munich Re Group as of 2017, I think. I am responsible for technical strategy across 3 areas: edge, cloud platform, and I mean, it depends if you want to separate it or not, but I consider AI and analytics to be its own category simply because of the impact that it has on our business. My work primarily revolves around our favorite toys in the space, predictive maintenance, optimization of operations, and also helping our customers go through more fundamental transformations in their business, CapEx, OpEx, enabling as-a-service models using the platform and tooling. I suppose my background's computer science, but my heart's been with analytics and AI, and it's something that I'm trying to inject in the company culture today as well. Based in beautiful Munich, Germany, and happy to be here tonight.
Great, thanks for joining us. And last but not least, Matt.
Hey there. So my name is Matt Trifiro. I'm the Chief Marketing Officer of Vapor.io. Vapor.io is an edge infrastructure company. We build edge infrastructure in what's called the middle mile. So the space between the internet and the access network. Our product is called the Kinetic Grid. We build this in the form of micro data centers, software-defined networking, high-speed core routers, and we connect cities together. We're building in 36 US cities today. I also am the co-founder and co-chair of the State of the Edge project, the Linux Foundation, and I host the Over the Edge podcast, which we're looking for second season sponsors. So if anybody's interested, please reach out.
Cool. Well, great. We have a great range of panelists here today. A good cross range on the industrial IoT side, as well as just looking to connect businesses and government in this very, very competitive market space. So first, I wanted, before we jump into this, I think that we kind of set the stage. We've talked about the state of the stack and kind of what that is, and the edge. And I think that for all of us in this industry, and especially for those that were attending the keynote this morning, I think that the common, I guess, topic around what does edge computing do for all of us. I think that there was a theme around low latency for real-time information, managing mission-critical business information and intelligence, and then, of course, this faster compute for high-volume data operations. And of course, along with all of that comes orchestration, management, and security, and all of these great things. I know Sam mentioned security. So before we jump into the discussion, I'd love to kind of get, for anyone want to just chime in, what else, besides those three benefits that I just mentioned, what else is really driving this whole conversation around edge computing when it comes to businesses and enterprises and even the entire ecosystem? Who'd like to take that on? Don't be shy.
Well, I'm happy to share some thoughts and welcome the other panelists to chime in. And if you think about the drivers, so we saw the evolution of cloud, right? Cloud first, and that made sense for different reasons, for different use cases. We've also seen the evolution and advancement of IoT platforms that are cloud-based. But I think where we're realizing is that there's certain needs of compute-intensive activities that need to be close to the edge. And based on latency, I mean, telecom costs are coming down. I know there was a session earlier on 5G, so we're looking at new technologies addressing some of the latency and speed and cost, hopefully, that's associated. But there's certain environments where it's realized that computing on the edge makes a lot of sense. I think the second element is that the computing capabilities and the analytics capabilities are a lot more advanced now than they were before. So now we're realizing that this edge to cloud story holistically makes a lot of sense.
Great. No, I agree with you. I think that those were some of the conversations that were had this morning. I think that there were probably some differences of opinion as to the term hybrid cloud and edge and cloud working together and in harmony, or that we're going to see this for the long haul. Those are some of the things. But I'd like to ask a question of Sam and Andrei, and I know that this is specific to IoT platforms. 5+ years ago, the industry, we all were joking about how many platforms were out there. Back then, it was 150 or so IoT platforms. And now, last year, I think they were talking about somewhere in the 500 range. So where do you see the IoT platform market heading over the next several years, and where will the value be realized?
Yeah. Should I go first? So,
Yeah, go ahead, Sam.
Go for it.
all right, sure. So thanks, Stephanie. Yeah, IoT is one of the fastest growing industries as we know it. But one of the things about IoT, the way it works today, is that it's a set of incompatible fragmented silos. So all of these systems are relying on the central cloud or proprietary gateways for managing almost all of their functions. And in order for IoT to become more impactful, we need to move to a fully connected Internet of systems, subsystems, and services. So today, all of the actions, decision makings for all types of applications is happening centrally in the cloud, which has been a major inhibitor in the growth of IoT applications. This needs to change to improve and speed up the decision making and actions and bring more efficiency into IoT and make these systems work more effectively and become more impactful. Now, there are few trends that will help with this. One is that IoT sensors and end devices are becoming smarter and more powerful every year, and they will soon be able to act autonomously and serve and collaborate with other devices without the need to go to the servers in the data centers or even gateways for every single function or transaction. So as a result, these autonomous connected devices, IoT devices, will become much cheaper to operate and maintain over time. Now, another thing is the creation of microservice-based solutions with APIs that will also make the management and maintenance of these systems much, much simpler over time. One last thing, which is important, is the growth of distributed ledger and decentralized finance technologies. That will create a seamless platform, peer-to-peer platform for the required business logic, which will open up a lot of possibilities to automate almost every activity, from paying for the gas at the pump to seamless entries to public event and almost any kind of digital transaction that you can think of. Andrei?
Thanks. So I suspect that next year, if you ask the same question, it will probably be 700 or 800, and the trend is clearly, I mean, it's clear to everyone, right? And it's in line with the market growth. I mean, I think we're talking around 30% per year for this space. When I hear the 500 IoT platforms, I do have to scratch my head a little bit, because I think we have to dig a little bit into what that number means, right? Is it horizontal platforms? Is it vertical platforms focused on some sort of asset class or some sort of industry or niche? Do they have an open market monetization strategy? All of these platforms, or are they simply, I suppose, silos very specific to the organization that's developed it? I think it's there's a lot of room for discussion here, but surely I don't think anyone should be surprised at the number of players in the market and given the growth trends. Now, I do expect a couple of movements in the next few years. One being consolidation. I think we already see a couple of big hyperscalers gobbling up a big section of the market. But I also see, and this will be very interesting to watch, even the hyperscalers moving up the stack. You know, they're taking care of piping now. They're thinking a lot about how do we bring data to the cloud? How do we, operationalize AI both on the edge and in the cloud? Create all of these nice pipelines where you can move models up and down. But they're also starting to look at, say, data products at a higher abstraction. And I think it will be interesting to see how the older players react to this. We'll probably see a lot more collaborative products between hyperscalers and companies currently developing IoT products. But surely, I would argue that the trend is towards consolidation.
Yeah, I'd have to agree with you on that. I think the other thing is I think there are a lot of so-called IoT platforms that aren't truly platforms in the clear definition of things. What does it offer, and are they actually do they have clients on that platform? Are they generating revenue? So there's a lot of players out there in the marketplace, and there's a lot of, I would say, static out there as well. So when the dust settles, which it will, we'll see who kind of leads in the marketplace and who kind of is leading in the direction overall. So definitely collaboration is on the will happen, and it will continue to happen. So Matt, so similar question to you. We have essentially no shortage of edge infrastructure players today. It's very congested. How do you see this shaking out, and who do you believe?
I actually disagree. I think there is a lot more infrastructure that needs to be built than we have companies building it today. So I don't think there's a shortage of infrastructure companies. I mean, if you think about like just the work that my company does, which is building out this middle mile, you know, there are 4,500-ish cities in the world that are more than 150,000, and 150,000 is just an arbitrary population, right? Ideally, we'd like this new internet to go everywhere. So there are, you know, tens of thousands of micro data centers that need to be deployed, you know, thousands and thousands of miles of dense metro fiber. There's a lot of work to be done, and I don't think there's a shortage. The other thing, and this is just, you know, my sort of biased opinion, I think most of the people that are in the infrastructure business aren't actually building complete solutions. You know, they're maybe deploying a data center, but they don't have the networking. So, you know, I think it's, again, you have to ask the question, what are you trying to solve for? Now, I think, and, you know, I wish I'd been in some of the other conversations earlier today, I think the magic number is 1 millisecond end to end. And that's just not the communication latency. That's the end to end. That's processing, that's communication, that's everything. Because once you get to 1 millisecond, the reality of creating a digital twin for the entire world and running a tactile internet and a metaverse and all this stuff that we want to do that I believe will radically transform everything from manufacturing to retail to entertainment, you need that. And that's very hard to build, and you have to have a lot of infrastructure close to the point of use in order to do that.
And with that, you know, you talked about the cities. What are some of the things that Vapor.io is doing in terms of building out this infrastructure? And I noticed that there's co-location, that you're getting closer and closer to the business, to the office, to the endpoint device, to the network, to the people. You know, what is it? What's really driving that? And how are you making those decisions on how you build out infrastructure?
Well, there's really two things. One is, you know, what's the long-term objective? And I just described that. That is to have enough infrastructure, enough compute, enough networking within, you know, 75 microseconds of where it's going to be used in order to run these new applications. But what's driving it today are the near-term use cases that are revenue generating. And I think the most obvious one is lowering the cost of complexity of densifying 5G networks. So it just happens to be that you need to have sub, you know, 100 microseconds between the remote baseband unit and the tower or the radio head in order to drive a 5G radio successfully. And so that is you know, a huge opportunity to use shared infrastructure and pre-built infrastructure to lower you know, to improve the economics of 5G. And once you have you know, the sort of communications layer in place, you know, offering private 5G in that same mechanism makes sense. And if you're delivering you know, a software-based RAN from a nearby data center, you might as well deliver all the on-premises services in a nearby data center, because, you know, a 75 microsecond you know, fiber link between a factory floor and a data center that's 10 miles away really is as if it's on premises. There's really no application that we've seen that can't survive. You know, obviously embedded compute and control loops and stuff need to be on-prem, but in terms of like IT equipment as we think about it. And so that's driving a lot of our investments today, is where are these concentrations of industry and retail that need these kinds of new technologies and are willing to sort of you know, fund the investment for the next generation of stuff.
It reminds me of the old switching industry, where we were developing co-location spaces through CLEX a long time ago. So great feedback. And so I want to jump over to Sanjay. So Sanjay, you mentioned, you know, your background in consulting and telecom. You know, now you're, you know, working with Siemens and heavily focused on industrial IoT. Where do you see value being delivered? And are there real differences when it comes to, you know, your focus on Industry 4.0, or even now everyone's talking about 5.0 compared to other sectors? I'd love to get your feedback on that.
Yeah, Stephanie, I guess there's sort of 3 or 4 key elements to that. It's the question always remains, how do I get value from this? I mean, we've done uh, quite a few projects. We've talked to our clients. We heard from them the value realized, and it ranges. I mean, the ROI they've seen on the projects we've done ranges from anywhere from 20 to 60%. It just depends how it's measured. And the way we look at where is the value being delivered, you have to look at it from sort of the equipment itself. Now, the equipment could be in a manufacturing floor, it could be out in the oil field, uh, depending, where the value is being realized or the need is generated. Then you look at sort of the plant level and the operations, and then look at the enterprise level. So you have to sort of look at all those elements as we start looking at the value statements from these initiatives. So if I'm looking at the equipment level, is it as efficient as it needs to be? What is this world of edge computing giving to me that I didn't have before? So I've had numerous conversations with clients about, well, we have a Lean Six Sigma, we have a Kaizen event, but in some cases we don't have the data to do the analysis to say what is the root cause for equipment failure. So that's where they're seeing value. If you talk to operations manager or plant manager, they're looking to say, well, I need to improve my quality and I've got my quality teams. What can I do with data, whether it's on the edge or on the cloud, right? It's all a matter of the amount of data that's needed to do things like predictive quality. So, for example, we have clients where we've been able to reduce the amount of inspection that's done on the products that's being manufactured because we can predict the quality based on the data and the analytics. So you're improving the efficiency of now your throughput and obviously quality of that line. At the enterprise level, when you say, I'm a VP of operations, why is it that certain plants are more efficient than others? Why is it that certain equipment is more efficient than others? What are those factors? And it's not always just data coming from the equipment itself. It's actually an aggregation of data from other sources. Well, what am I producing? If I'm producing the same item in the same plant, my equipment, why is there variation? Is there a correlation between the training level of the person that's actually performing that operations? Now you start getting into more complex information, and we talk about, right, how is the industry evolving, where is it going? So that's what we are seeing is you're getting more from sort of single elements of data sources to now data from multiple sources that are being aggregated and you're getting insights. I think the last point here is, you have to quantify the value. You have to obviously start with a problem statement. Like, what is my problem statement? They just don't want to adopt IoT because it is the thing to do.
Right.
And one last thing I'll add real quick is, as we talk about edge to cloud, one of the things from a value generation perspective is also think about all the applications now that you're going to deploy on the edge. So what's the way to manage that? I remember back in the day, we have CDs and floppy disks, those who were in that age. Now, we've consciously taken the effort to say there has to be an edge management system. So I can centrally manage and deploy my applications like the App Store for industrial manufacturing or industrial operations. So that's something that we are heavily invested in.
Great. That's good feedback. I think that from a consistency perspective, you talked about things like predictive maintenance and anomaly detection, improving efficiency, all things that I think manufacturing, those in the supply chain, those have been very common things in terms of the outcome that they're expecting in leveraging IoT and edge computing. So I want to jump over to Sam. So what do you see as the relationship between IoT and edge computing? Because this theme really is about both of these things coming together and how we leverage this to improve, to transform businesses. So more particularly, like, how does this really impact state of the stack? Maybe give us your feedback around that.
Sure. So both are completely interrelated, in my opinion. Edge computing will help transform Internet of Things to Internet of Systems and subsystems. We talked about all these different platforms, systems from different suppliers out there needing to talk to each other. Edge computing is what will enable that unification and will bring all of this together to work and collaborate with low latency requirements like the 1 millisecond that was mentioned. You need a lot of this processing to happen within the devices themselves where the data is being used. When you look at it, I mean, there are billions of devices, IoT devices, that are producing a substantial amount of data on the edge. And these devices have enough processing power to process this data on the devices. They also have network connectivity to send and receive information, for instance, commands, policies, etc. Now, IoT solutions need edge compute capabilities so they can translate this raw data into meaningful information and share that knowledge amongst other devices, without the need to go to the central cloud for every single transaction, and also prevent this notion of data avalanche that has been the cause of a failure in many IoT applications. Just according to Bain & Co., like the report in 2019, it was mentioned that majority of IoT implementations have failed due to high cost of cloud and latency in communication. And that's just on top of the data avalanche issue that I just mentioned. So in the world of IoT, there's also many scenarios, situations where a collection of heterogeneous devices from different suppliers are either connected to the same network or are in proximity to one another. Now, once these devices can act autonomously using edge computing with minimal reliance on the cloud, and can directly communicate with each other using hybrid edge cloud, for instance, for configuration or processing of a workload, we will see very impactful use cases developed and released to the market. Now, another important enabler that I want to highlight in IoT is the edge-based data centers, including multi-access edge or MEC that telcos will provide. This will also create additional computing resources closer to where data is originated and consumed. This way, we will have a cloud that starts from the end devices where the applications are running all the way to the backend. So as a result, we will see a lot more efficiency, lower latency, better processing time, so on and so forth. In fact, there is a white paper that we just recently published on MEC plus mimik that I highly encourage the audience to check it out. So I may include a link to that in the chat. So having said all of that, edge computing will accelerate the growth of IoT and will turn IoT into a massive business that is much, much larger than what it is today, and will help drive automation in almost every industry segment. So that's what I think. Edge computing is very much related to IoT, and one needs the other to grow, basically.
Well, thank you, Sam. So I want to jump over to talk a little bit more about the use cases. I think that we're talking about infrastructure, the stack. We've already talked about different technologies and things coming together and the collaborative efforts that are needed in the entire kind of ecosystem of partners that are out there today. Now let's talk about the pandemic. In terms of use cases, we're hearing out there that there's actually been an increase of businesses are increasingly adopting different IoT technologies or solutions that, and it's strictly tied to the fact that their workforce is now working remotely, and they're looking to automate. They're looking to augment some of the gaps that they're experiencing in the market. Maybe I'd love to hear your perspective on the impact of the pandemic to the market as a whole, and then maybe talk about some of the other interesting use cases that might be appearing, that might be new or very interesting, that you're seeing in the market that's really driving the need. And Matt, I'd love to get your feedback around this new infrastructure bill and maybe the possibility of that funding in the U.S. coming down the pipeline for these cities that are really looking to boost up their infrastructure.
Yeah, so the answer to the first part of your question, I'll take both of them quickly and then everybody else can jump in. So the answer to the first part of your question, what I've seen is, every company that wants to be around in a decade has some sort of a digital transformation or automation plan that they were maybe going to take 5 to 10 years to implement. Well, now they're trying to do it in 2 years. And the reason is you can't afford to shut down your factory because of the next pandemic. In addition to, because your competitors are starting to do it, now you've got this competitive pressure to do it. So that sort of has created this virtuous cycle of investment and focus around accelerating a lot of the Internet of Things and digital transformation and robotics and factory automation and et cetera. So that's the biggest impact I've seen from COVID. In terms of new applications, obviously we've all experienced the sort of rudimentary form of telemedicine, which looks like Zoom today. But at some point it's going to be very different. People say, well, never robotic surgery. Well, that's not true. Robotic surgery already happens. I don't know if you've ever watched LASIK surgery, but the doctor pushes a button, right? And then the computer does everything else. Drives the laser, shuts it if you blink your eye. I mean, so the doctor doesn't have to be in the room to push that button or to set up all the parameters for it. So I do think that things like robotic surgery and so on will come out of that. I think that from a network traffic standpoint, the biggest change has been that people are working from home, students are working from home, and I think that that's going to extend into quite a bit of the future. And so the edge infrastructure we've been building actually helps mitigate the congestion that created.
Anyone else? Andrei, did you want to chime in on some of the use cases, some of the things that you're seeing?
Sure. I mean, COVID had a very practical effect for us. We couldn't send field engineers on site for a while, so I suppose you can look at that as being stalled. I don't think it meant much of anything for the development of the technology itself, but it confirmed, as if that wasn't already obvious, I think the importance of being able to, deploy in a very seamless way, zero-touch deployments as an example, remote monitoring, orchestration of assets. It's very important, I think, to not have to send technicians every single time something is off with a device on-prem. I think it's also interesting to think about how COVID has accelerated this need for remote collaboration, right? I will be very curious to see where, say, technologies such as NVIDIA's Omniverse, for instance, will take us. Virtual factories of the future, they call them. Of course, it's very embryonic, I suppose, but this is clearly the direction where we're looking to essentially map the physical world to some sort of real, true digital twin that can be, that workers can interact with, that they can train with, as an example, that they can test new workflows with, and of course, there's an entire infrastructure required for data collection, for low latency processing of data that has to go hand in hand, and I'll be very curious how these two worlds converge. Also, obviously, AR, VR, they seem like toys, but now they seem to be more relevant than ever, I would say. I mean, as for other use cases around predictive maintenance and anomaly detection and all of these good things very relevant to the industrial space, for sure, still on the front line, but probably a few new things on the horizon as well.
Okay, so we have about 6 minutes left. So even though we had a lot of content that we were wanting to cover, I think we should jump to questions. We did have a question from, I don't know if it's Michael Berger or, Michael Berger, asking about the peer-to-peer communication. I think that you're talking about blockchain. He said, why is that important? And is it enabled by the ad hoc edge service meshes that can be created between the nodes at the edge? Maybe, Sam, you want to talk about, maybe address that question since you were talking about blockchain?
Sorry, was this pointed to me?
Yes. Strictly, well, the question was around peer-to-peer communication. The question was asking around Is this enabled by the ad hoc edge service meshes that can be
Yes.
created between nodes?
Yes, absolutely. So really, what we're proposing here is a microservice-driven API with API architecture that now is being done on the front-end applications right on the devices, which now enable microservice mesh amongst devices, and that's what's gonna basically enable these applications to be able to communicate directly through ad hoc service mesh that gets created amongst them. And all of it is basically at the application level. When the developer uses our platform to develop their app, they basically develop it in a microservice architecture, and which is very different than the way things are being done today, because as you know, on the device it's just a client app and everything happens on the servers. Now we're bringing some of that down to the application in form of microservices, and we're enabling this ad hoc service mesh amongst the devices and applications.
Okay, I'm going to jump over to another question. This one's interesting by Sean D. He says, he or she, I'm not sure, monitoring deployment seem like common criteria in edge stacks. What is lacking is a sense of traceability. If something goes wrong, which edge is responsible? Like, how do we kind of go through that and identify that? What are some of the thoughts around this? Anybody want to take that one on?
Maybe I can take a stab. So we talk about, at least in relayr, about equipment as a service, and I think it's important to recognize one fundamental issue with this. We are essentially looking to release invoices based on usage data coming from assets, and this data traverses quite a few hops in its life cycle. It goes through the OT domain, it goes through the IT domain, and it goes through a couple of infrastructure pieces that we probably have very little control over. Now, I would argue that even regulation hasn't really caught up to this problem, but I suspect that we will have to have a conversation in the very near future around how we fingerprint data across both OT and IT. Talking both around touching on blockchain, I suppose, but even touching on more fundamental issues around how do we verify the integrity of data, say at a POC level as an example. And these are really challenges that are currently unresolved. I know Siemens is dabbling in it for what it's worth. But again, very, very embryonic, I think.
Okay, so a final question since we have a few minutes. And so what are some of your predictions for what's going to happen over the next year? What are some of the driving factors? What are you most excited about? Would love to get your 10-second 2 cents, and if we could do a round on that, let's start with Sam.
Sure. So definitely it will be another year that we see more growth in IoT applications and platforms. A lot of this increase in AI, ML related applications, robotics, automated manufacturing. Definitely edge computing becoming more and more important as with the increase in the number of IoT devices generating loads of data at the edge. It does seem that healthcare and manufacturing use cases will dominate, like and telemedicine. It's now something that is being discussed more than ever. Hopefully, there will be some infrastructure spend that will help smart city related concepts to be implemented. So all in all, I think some key focus improvements will be around security, privacy, and enabling edge computing, including edge AI.
And Sanjay, you want to chime in on that one?
Yeah, I think what I'm excited about, I think all of us who are attending, really, we are sort of at the pivoting edge of what we've seen and how technology adoption has accelerated. So I'm very hopeful that folks who are in the manufacturing business operations are looking at this. They're seeing that technology adoption does make a huge difference. And this is the time to take the leap and just experiment with edge computing, IoT. Just take a step. It doesn't take long to get started. It doesn't cost a lot to get started, but don't hesitate. That's my view of what's happening and what should happen.
And Matt.
What was the question? I'm sorry.
Oh yeah, what are you most excited about over the next?
Oh yeah, well, I do think, and I brought it up earlier, and some other folks talked about it. I do think that our ability to create what amounts to a digital twin of the world. I mean, we talk about the Internet of Things. It's really the Internet of everything. I mean, anything that's powered, even some things that are, self-powered, like RFID chips, will be connected to the Internet. It's inevitable. And what we can do with that from a simulation, experimentation, analyze, respond, activate loops at very low latency is going to be completely profound and change everything in our lives. So that is what I'm most excited about.
Great. Well, so that ends our session today. I think we're a minute over. I hope that we're not sitting on someone else's session. So I want to thank everyone for joining us today. This will be available for playback.